Hello everyone, welcome to Numeriq Learning. Today is day 49 of the Do Math With Me series. At present, we are solving a lot of questions from some applications of trigonometry, which happens to be the 9th chapter in your class 10th mathematics. Let's get started. The very first question of the day is, the angle of elevation of the top of a tower from a certain point is 30 degrees. If the observer moves 20 meters towards the tower, the angle of elevation of the top increases by 15 degrees. Find the height of the tower. In this particular chapter, as soon as you are given a question, it is always important that you have to draw it in order to be able to visualize where is your right angle triangle and where is your theta angle. So it's very important that as soon as you read the question, let's draw the figure. Okay, so here the angle of elevation of the top of a tower from a certain point is 30 degrees. Okay, so now let us draw this. So this is that certain point on the ground, and the angle of elevation of the top of the tower, let this be the tower. Okay, let this be the tower, and the angle of elevation of the top of the tower from a certain point is 30 degrees. So this is your horizontal. This happens to be your 30 degrees. The observer is right now here. Okay, probably at a point C, the tower is AB. Okay, this happens to be your tower. If the observer moves 20 meters towards the tower, that means the observer is moving. Initially, he is at the point C and he is moving 20 meters towards the tower. Okay, let's say this is a point D. And he has moved 20 meters, right? Now what happens? After the observer moves 20 meters towards the tower, the angle of elevation of the top increases by 15 degrees. What does it mean? Now from here, from this new point D, the angle of elevation increases by 15 degrees. Means what? Original angle is 30 degrees. This 30 degree, it has increased by 15. What is 30 plus 15? It is 45. So this new angle of elevation is 45 degrees. Okay. We don't know how far is this observer from the tower. So let it be x meters. You have to find the height of the tower. So let this be your height of the tower, capital H. Right? This is 90 degrees. So we can very well mark our hypotenuse. This is angle. If your angle theta is here, the side which is right in front of your theta degree happens to be your perpendicular. This is your perpendicular, right? And the below one is your base. In either side, both the scenarios. So we have marked everything. Okay. So if you're asked a similar question in your exam or a test, how should you write? You can write, let AB be a tower of height H meters. Angle ACB, right? Angle ACB is equal to 30 degrees. Angle ADB, that is your new angle after the observer has moved 20 meters, is nothing but 30 degrees plus 15 degrees, which is 45 degrees. Let CD, the distance that he walked from the initial to final point, is 20 meters. And let DB be x meters. Right? Now, in triangle ABC, you have to find out the perpendicular. H is what you have to find out, right? So this is your perpendicular, and you know what is base, what is the base. If you consider triangle ABC, the outermost triangle, then your base will be 20 plus x. Your perpendicular will be H, and you have to apply tan ratio, so tan of theta or tan 30, right? So let me directly write tan 30 equal to P by B. Perpendicular is nothing but capital H. Base is nothing but 20 plus x. What is tan 30? It is 1 by root 3 is equal to h by 20 plus x. Right? Cross multiply, what do you get? Root 3h is equal to 20 plus x. Right? Let us write x in terms of h. X is equal to root 3h minus 20. Right? Let this be equation 1. Now let us go to the smaller triangle. In triangle ABD, what is tan 45? Is nothing but P by B. P is nothing but your H. By base is nothing but your X. What is tan 45? It is just 1. 1 is equal to H by X. Cross multiply. You will get X is equal to H. This is equation 2. So from 1 and 2, what do you get? Can you equate it? Yeah. So you can write from 1 and 2. We can write root 3h minus 20 is equal to h. Rearrange the terms. So root 3h minus h is equal to plus 20. Take h common out. You will have root 3 minus 1 is equal to 20. So what is h? Capital H equal to 20 divided by root 3 minus 1. You can rationalize the denominator by multiplying numerator and denominator by just the opposite of the reciprocal of the denominator, that is root 3 plus 1. Okay, so this is nothing but 20 multiplied by root 3 plus 1 whole divided by a plus b into a minus b, that is a square minus b square. So what do you get? So capital H, that is the height of the tower, is equal to 20 multiplied by root 3 plus 1 divided by root 3 the whole square is 3 minus 1, which is 2. So 20 multiplied by root 3 plus 1 divided by 2. So you can cancel out 2 tens are 20. So what do you get? What is your height of the tower? It is 10 multiplied by root 3 plus 1 meters. So this is the height of the tower. Okay, that's your answer. Is it clear? I hope you understood. You have to just apply tan theta in both the triangles and calculate h. It's a very, very good question, very easy question, and it has come in the previous board exams multiple times. So let's move on to the second question. If 1 plus sine square theta is equal to 3 sine theta cos theta, then prove that tan theta is equal to 1 or 1 by 2. Let's write what is given. Okay, you are given 1 plus sine square theta. Let me write it completely. 1 plus sine square theta is equal to 3 sine theta cos theta. Let us divide both the sides by sine square. Okay, because we have to get tan theta. So let us divide both sides by sine square theta. So what do you get? 1 by sine square theta plus sine square theta divided by sine square theta is equal to 3 sine theta cos theta divided by sine square theta. So now 1 by sine square theta will be 1 by sine square will be cosecant square theta. Cosecant square theta plus these sine square will get cancelled. This sine theta and one of the sine theta will get cancelled. So here it's 1 is equal to 3 cos theta by sine theta. So I'll directly write cot theta. Identity that is related with cosecant and cot. What is that? It is, so you can write, we know that cosecant square theta minus cot square theta is equal to 1. Or you can write cosecant square theta is equal to 1 plus cot square theta. So we can replace cosecant square theta with 1 plus cot. square theta. Okay, so here in place of cosecant square theta, I'm going to replace it with 1 plus cot square theta. So you can write 1 plus cot square theta. Again, there is a plus 1 is equal to 3 cot theta. Right? Okay, 1 plus 1, 2. So we'll bring everything to this side. So cot square theta will bring plus 3 cot theta from RHS to LHS. So minus 3 cot theta plus 1 plus 1, 2 is equal to 0. Okay, now this is very similar to your quadratic equation. This is like of the form, say, x square, where x is cot theta, x square minus 3x plus 2. Right? So if your sum is minus 3, your product is 2. So product is 2 means 2 ones are 2. If the sum is minus 3, you have to add negative on both the sides, right? Minus 2 minus 1 is minus 3. Minus 2 multiplied by minus 1 is plus 2. So what can you write? So these are the two factors for your middle term, right? Similarly, here we'll write the same thing, but in place of x, we'll write cot theta. So cot square theta minus 2 cot theta, doing the middle term splitting, minus cot theta plus 2 equal to 0. Correct? Take cot theta common out. So you will have cot theta minus 2 minus 1 multiplied by cot theta minus 2 equal to 0. So what is the first root? Cot theta minus 2, and the second one is cot theta minus 1 equal to 0. Right? So what do you get here? What are the two roots? So you have one is cot theta minus 2 equal to 0, and the other one is cot theta minus 1 equal to 0. So cot theta equal to 2, or you will write cot theta is equal to 1. Right? And what is cot theta? If you have to find tan theta, what will you do? So tan theta is equal to 1 by cot theta, isn't it? So 1 by 2 is 1, and the other one is tan theta equal to just 1. Am I correct? So what do you have to prove? What have you shown now? See, prove that tan theta is equal to 1 or 1 by 2. So that's what you have written. Therefore, we have proved that. Therefore, you can write tan theta is equal to 1 by 2 or 1. Hence proved. So just remember this identity here. Okay, this one is very important. Cosecant square minus cot square equal to 1. Similarly, secant square minus tan square is also equal to 1. Let's move on to the next question. Yeah, if sine theta plus 2 cos theta equal to 1, then prove that 2 sine theta minus cos theta equal to 2. Again, it's very, very easy. Let's do it. Let's write what is given. So sine theta plus 2 cos theta is equal to 1. Let's square on both the sides, because the only identity that we know which relates sine and cos is sine square and cos square. So we neither have sine square nor cos square. So let's square it. So what do you get? Squaring both the sides. Okay, so here you will have sine theta plus 2 cos theta the whole square equal to 1 square, which is 1. A plus b the whole square. So what is it? Sine square theta plus b square. 2 square is 4 cos square theta plus 2ab. So 2 into 2, 4 sine theta cos theta is equal to 1. Now, let us convert this sine square theta into 1 minus cos square theta. Right? And let us convert this cos square theta into 1 minus sine square theta. Okay, so here what is sine square theta? It is 1 minus cos square theta. I'm putting it in the bracket, plus 4 multiplied by cos square theta. I can write it as 1 minus sine square theta plus 4 sine theta cos theta is equal to 1. Open the brackets. What do you get? 1 minus cos square theta plus 4 minus 4 sine square theta plus 4 sine theta cos theta is equal to 1. Okay, so here let's take all the numerals to right hand side. So what is left is minus cos square theta minus 4 sine square theta plus 4 sine theta cos theta is equal to 1 minus 1. This 1 goes to the other side. Plus 1 goes to the other end. It becomes minus 1. Plus 4 goes to the other end. It becomes minus 4. Right? So this plus 1 minus 1 will get cancelled. Here you can take a negative common out. When you take one negative common out, what will you have inside? Cos square theta plus 4 sine square theta minus 4, because you have taken negative 1 outside. Yeah, you have taken negative common out. So plus will become minus 4 sine theta cos theta is equal to minus 4. This negative and this negative will get cancelled. Okay, now here this is of the form, let me write it. See, cos square theta, see cos theta the whole square plus 4 sine square theta, I can write it as 2 sine theta the whole square minus 2 multiplied by cos multiplied by 2 sine. This is what is 4 sine cos, right? Is equal to 4. What is the expression that you have on your left hand side is of the form a square plus b square minus 2ab, which is a minus b the whole square is equal to 4. What do we now need? We need 2 sine minus cos. Okay. 2 sine minus cos. So what I will do here is, in place of, we can go one step back and rewrite it such a way that, so I can replace this, right? This can, so this is of the form cos square theta plus this is also, I can, it's the same as writing 4 sine square theta plus cos square theta minus 4 sine theta cos theta. Isn't it? Is equal to 4. So I can write 2 sine square, 2 sine the whole square plus cos the whole square minus 2 into cos into 2 sine equal to 4. Yeah. Now it's of the form a square plus b square. So now I can write a minus. So 2 sine minus cos the whole square, because that's what I need in the proof. 2 sine minus cos, isn't it? So 2 sine theta minus cos theta the whole square is equal to 4. So what is 2? Taking the square root, 2 sine minus cos is equal to 2. Okay, so I can write it elaborately. So 2 sine theta minus cos theta is equal to 2 is what I have to prove. 2 sine theta minus cos theta equal to 2. Hence proved. Now why is this question a little tricky to do is because you need to practice and understand the reason why we are first of all squaring both the sides, converting sine. Okay, you are applying, you're squaring both the sides, converting sine square to 1 minus cos square, converting cos square to 1 minus cos square, and simplifying it, and then applying the algebraic identity that is a minus b the whole square. So this is quite a good question, but there's nothing new about it. All you are just doing is applying the identities, that is sine square theta plus cos square theta is equal to 1, sine square plus cos square equal to 1 at multiple places, and this commonly used algebraic identity in order to prove this result. But just rearrange the terms in a way that gets you the required result. Okay. Let's move on to the next question. The angle of elevation of the top of the tower from two points distant S and T from the foot are complementary. Prove that the height of the tower is root ST. What do you mean by when they say complementary? The angle of elevation of the top of the tower from 2 points distant S and T from its foot are complementary. The angle of elevation are complementary. What does it mean? When you say two angles are complementary, if you say two angles X and Y are complementary, it means their sum is equal to 90 degree. Complementary means 90 degree. Okay, suppose you have x and y, or if you can probably say alpha and beta. If alpha and beta are complementary angles, which means what? The sum of alpha plus beta is equal to 90 degree. Right? If alpha is equal to theta, then what will be beta? Beta will be equal to 90 minus theta. This is what it means when you say complementary. Okay, now let us draw the diagram. So the angle of elevation of the top of the tower from 2 points S and T from its foot are complementary, right? So let's draw the tower first of all. So let this be the tower and let this be the 2 points on the ground, right? Let me draw the angle of elevation of the top of the tower from both the points and also draw the horizontal. Right? Okay. Now, so let this be your initial point A, B, C and D. Okay, this is the tower of height h. AC is the tower of height h. Now, you can tell me, always suppose if theta is 30 degrees, right? If theta is say 60 degrees, 90 minus 60 will be 30 degree, right? So which of the two will be theta? So the first one, if the angle is theta, this smaller angle will be 90 minus theta. Am I right? 90 minus theta. So the first distance, what is it given from the 2 points? S and T distance from its foot. So the first point is at a distance of S meters and the second point is at a distance of T meters. You have to prove that the height of the tower is equal to root of ST is what you have to prove. Okay, again, very easy. So you can, I think on your own write. If you're writing the same, if you're solving the same question, you should write, let AC be the tower of height h. Let angle ABC be theta angle theta. Let BC be the distance S. Let angle ADC, since it's complementary, ADC will be 90 minus theta. The distance from D to C is T. All of these details you have to write separately. But let's get to the main proof. Okay, so let's take the smaller triangle ABC. So in triangle ABC, obviously we are going to take tan. So tan theta is equal to P by B. What is your PH? What is your BS? Okay, let this be 1 because we don't know what is theta. So let it be as it is. Now let us take the bigger triangle. In triangle ADC, the same thing. Tan of 90 minus theta is equal to H by T. Okay. Now, there's something which you need to know. Always remember, tan of 90 minus theta is equal to cot theta. Okay, this is what these are complementary angles. Tan of 90 minus theta is equal to cot theta. So let me put it in a box so that you will remember it. Complementary angles in trigonometry. Okay, tan of 90 minus theta is equal to cot theta. Now what I can do, let me mark. So I can replace 90 minus theta. Tan 90 minus theta is cot theta, right? Cot theta is equal to H by T. So what is 1 over tan theta? 1 by tan theta will be 1 by H plus T. So you can just you can just flip it up. So T, or you can write probably 1 by tan theta is equal to, it's the same thing, H by T, right? I'm not flipping it. I'm just keeping it the same. I have just written cot theta is equal to 1 by tan. Therefore, you can just keep it as it is and mark this as equation 2. Okay. Now, from 1 and 2, you have to multiply 1 and 2. So, when you multiply 1 and 2, what do you get? Tan, in the LHS side, you have tan theta multiplied by 1 by tan theta. is equal to h by s multiplied by h by t. Tan theta gets cancelled. So 1 is equal to h square by st, cross multiply, st is equal to h square, or h square equal to st. Take the square root, h is equal to root of st. You will not take the negative, you will only take the positive meters. Hence proved. Okay. So remember here, in place of cot is nothing but 1 by tan. I have not done any change. So if I had written 1 by cot, then I would have written 1 by h by t, which is equal to t by h. Right? So I hope this part is clear. Okay, we have not changed the value at all. We have just written cot in terms of tan. It is just 1 over tan, and we have multiplied that with equation 1. So tan into 1 by tan will give you 1. You have to just, all you need to have is eliminate theta and only have everything in terms of height and the distance. Right? I hope it is clear. Let's move on to the next question. Yeah. The shadow of a tower standing on a level plane is found to be 50 meter longer when the sun's elevation is 30 degree. The shadow of a tower standing on a level plane is found to be 50 meters longer when the sun's elevation is 30 degree than when it is 60 degree. Find the height of the tower. Let's draw the tower first of all in order to be able to visualize this. So let this be your tower. And what are you given? The shadow of the tower. So you will have probably, let this be the shadow of the tower. Okay. The shadow of the tower standing on a level plane is found to be 50. So probably this is the shadow at the beginning, and then you are given the shadow of the tower standing on a level plane is found to be 50 meter longer when the sun's elevation is 30 degree than when it is 60 degrees. So initially this is 60 degrees. Okay, this is the initial angle of elevation, 60 degrees. What they are saying is the shadow length is 50 meter longer. Okay, when the angle of elevation of the sun is 30 degrees. Okay, so this is 50 meter longer. Let this distance, initial distance, be x. H is the height of the tower which you have to find out. The distance of the shadow when the elevation is 30 degrees is given. Right? So let's just mark. This is the shadow, probably is P, Q, R. And you have your sun here. Okay. So that's all. Now you have to just solve and find the height of the tower. So first in triangle SPQ, in the longer triangle SPQ, in triangle SPQ tan 30, you can apply tan 30 equal to P by B. P is H by B is 50 plus X. Tan 30 is nothing but 1 by root 3 is equal to H by 50 plus X. Cross multiply and write X in terms of H. So 50 plus X is equal to H root 3, or X is nothing but H root 3 minus 50. This is equation 1. Now let us take the smaller triangle. In triangle SRQ, tan of 60 is nothing but H by X. What is tan 60? Is root 3 equal to H by X. So what is X in terms of H? X is equal to H by root 3. Let this be equation 2. So from 1 and 2, what do you get? So from 1 and 2, H root 3 minus 50 is equal to H by root 3. You have to calculate H. Just solve it. So we can take H root 3 minus H terms on one side and the constant 50 on the other side. H common. So root 3 minus 1 by root 3 is equal to 50. Okay, take the LCM and then cross multiply. LCM is root 3. So you have 3 minus 1 is equal to 50. Okay, so h multiplied by 2 by root 3 is equal to 50. And what is h then? H will be equal to 50 root 3 by 2. You can cancel it. Okay, 25 root 3 is what you'll be getting. So height is 25 root 3 meter. This is the height of the tower. I hope you understood. Yeah. So it's a very, very good question. Always make sure that you draw diagrams very, very clearly. Okay. Let's move on to another question. Yeah. So here the question is, a vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff of height h. At a point on the plane, the angle of elevation of the bottom and top of the flagstaff is alpha and beta. Let's draw the diagram. So a vertical tower. So suppose this is your vertical tower, stands on a horizontal plane, and this tower is surmounted by a vertical flag. Okay, so let this be your vertical flag. Right? At a point on the plane, the angle of elevation of the bottom and top of the flagstaff. So let this be the point on the ground. The angle of elevation of the bottom and top of the flagstaff are alpha and beta respectively. So the alpha is nothing but for the bottom one, the first one. This is alpha, and for the top it is beta. Prove that height of the tower is that expression. Okay. So let capital H be the height of the tower. Say P, you can mark it as Q, PQR, and let this be your flagstaff F. The distance between the point at which the observer is situated and the tower, let it be x meters. Right? Let the height of the vertical flagstaff which is surmounted above the vertical tower, this flagstaff, let it be of height small letter h. This is your tower. Okay, and this is the flagstaff. Let's take first of all the smaller triangle, that is in triangle PRQ or PQR. What is tan of alpha? Tan alpha will be equal to capital H perpendicular by x, or I can write x in terms of h. So x is equal to h divided by tan alpha. Let it be equation 1. Now let's take the bigger triangle. In triangle FQR. FQR, what is tan of beta? Tan beta is equal to the total perpendicular, right? The bigger triangle. Total perpendicular is small letter h plus capital H. So h plus h divided by x. Again, you can write x in terms of h. X is equal to h plus h divided by tan beta. Let this be equation 2. Same way. So from 1 and 2, both are equal to x. So let us equate it. So you can write h by tan alpha is equal to capital H plus small letter h divided by tan beta. Okay, cross multiply. So I got h multiplied by tan beta is equal to h plus small letter h multiplied by tan alpha. Okay, so h tan beta equal to h tan alpha plus h tan alpha. Okay, you can take it to one side. So h tan beta minus capital H into tan alpha equal to, because capital H is the height of the tower, small letter h tan alpha. Okay, take h common out. What do you get? Tan beta minus tan alpha is equal to h into tan alpha. What is capital H equal to? This is the height of the tower. Equal to small letter h tan alpha whole divided by tan beta minus tan alpha. This is what you need to prove, and this is what you have got. See, h tan alpha divided by tan beta minus tan alpha. Hence proved. Yeah, please do this question on your own and see if you are able to get this.